What is our place in the Milky Way and our place in the universe? In ancient times, many people had the idea our planet Earth to be at the center of the universe, as stated by Aristotle and Ptolemyus in their Ptolemaic. According to this model, Earth is at the center of the universe, and all the other celestial bodies orbit around it. Today, lots of people think the same. But is this really the case? To answer this question, let's try to travel in the universe through space and time. We will start our journey from our planet to reach, in the end, the extreme boundaries of the universe. During the 16th century, Galileo Galilei, the famous Italian astronomer, was one of the first people, during modern age, to have some doubts about the geocentric model of universe. Thanks to telescopic observations, he was able to demonstrate our Earth is not at the rotation center of planets and the Sun, but really it is the Sun itself. Moreover, observing planet Jupiter, he discovered that the giant planet is the rotation center for its moons. So, Galileo became aware that the center of the solar system was the Sun, not the Earth. The solar system is made by a star, the Sun, 8 planets, and different types of minor celestial bodies, like comets, asteroids, and dwarf planets. Well, the Earth isn't at the center of the solar system. Maybe it is the closest planet to our Sun. No, it isn't, because it is only the 3rd planet from the Sun. The closest planet to our star is Mercury, followed by Venus, and then Earth. The Earth moves around the Sun, our star, just like all the other celestial bodies in the solar system do. This implies that the Sun, and not our planet, is the center of rotation of the solar system. The Earth takes a year, 365 days, to travel its orbit, and its average distance from the Sun is 150 million kilometers, which is the measure unit of distances in the solar system known as the astronomical unit, and abbreviated as AU. Why do we talk about average distance? Because the orbit traveled by the Earth around the Sun is not circular, but elliptical, and this means that there will be an aphelion, the point of the Earth's orbit farthest from the Sun, just over 1 AU away from it, and a perihelion, the point of Earth's orbit closest to the Sun, just under 1 AU. An alternative way to define the astronomical unit passes through the light time. In particular, we can say that the average distance from Earth to Sun is equal to about 8 light minutes. This means that sunlight takes 8 minutes to arrive on Earth, so that the sunlight we see at a certain moment is not that of that moment, but it is the sunlight which left from the Sun 8 minutes earlier. In other words, if the Sun went out, for example, at 2:30 p.m., we would only notice it at 2:38 p.m. Or again, if you could travel aboard the Star Wars Millennium Falcon, it would take you only 8 minutes to travel from the Sun to the Earth, when in reality it takes a few years. To give a more concrete idea of the dimensions of the solar system, if the Sun were a sphere with a diameter of 14 centimeter, Pluto would be at 700 meters from the Sun, like 7 regular soccer fields. The nearest celestial body to Earth is the Moon, our satellite. To reach it, you should take 3 days off. It's the same time taken by Apollo astronauts to cover the distance of nearly 400,000 kilometers that separate the Moon and Earth. But if you had Star Trek Enterprise and traveled at maximum curvature, you would only take less than 2 seconds to reach the Moon. Now let's begin to move towards the outer solar system. At a distance of 2 to 3 AU from the Sun, between the orbits of Mars and Jupiter, we would meet the asteroids' main belt. Asteroids are those small rocky bodies whose dimensions span from a few kilometers to a few hundred kilometers. They are so small that they aren't visible through unaided eye, but only through telescopes. We could reach asteroids in a few years with a traditional spaceship or probe. Let's move on. We would need around 10 years and 40 AU to fly by Pluto, one of the outermost bodies of solar system. Try to imagine it in your mind. If you were on Pluto's surface and had a look to our planet, you would only see a pale blue dot. That is the same sight captured in 1990 by Voyager 1 NASA probe while it was leaving Neptune behind. Around Earth, only the dark vastness of the universe, barely illuminated by starlight. Now we have left behind our solar system, and we're going to enter interstellar space. To get to Proxima Centauri, the closest star to Earth, we have to cover a bit more than 4 light years. We remember a light year is the distance covered by light in a year in the vacuum and is equal to about 10,000 billion kilometers. Distances begin to become big, since the Millennium Falcon would take more than 4 years, traveling at light speed to reach Proxima Centauri. And what about the Sun? Okay, it's at the center of the solar system, but is it also at the center of the Milky Way? If you continue to travel on board your beautiful spaceship, you will discover it. But it's a very, very long trip, so you will need much patience. The Milky Way is our galaxy. It is an immense group of stars held together by the force of gravity. It has the shape of a flattened disk with a bright core in the center, where the star density is very high and spiral arms around it. Around the core there is a spheroidal halo, which extends outside the galactic planet. At this point, it could be useful to introduce the parsec, equivalent to 326 light years, to measure the dimensions of our galaxy. So, our Milky Way has a diameter of around 30,000 parsec, which are equivalent to 100,000 light years. So, if we were back on the Millennium Falcon again and had to cross the Milky Way from one side to the other traveling at the speed of light, the fastest thing there is, it would still take us 100,000 years to cross it all. Or to put it another way, if you were to send a WhatsApp message to your friends on the other side of the galaxy to decide what to do on the weekend, your message would take about 100,000 years to arrive. Assuming that your friends respond immediately to the message, the response would take another 100,000 years to get back to you. Keeping the same analogy seen before, with the Sun represented as a 14-centimeter diameter sphere, our Milky Way would have a dimension of 100 million kilometers, that is equivalent to make 2,497 turns of the Earth along the equator. The galactic halo has a diameter of the order of 30 kiloparsec and is populated by old stars that are stars with an age double that of the Sun. In the spiral arms, instead, there are younger stars, like the Sun, located within the arm of Orion, a secondary arm of the Milky Way between the arms of Perseus and Sagittarius. Our star, the Sun, is only one of the estimated 200 billion stars in the galaxy. Our galaxy, in fact, its name derives from the Greek galaxias, the way of milk, referring to an ancient Greek myth for which the Milky Way would represent nothing other than the milk sprinkled out of the breast of the goddess Hera while nursed little Hercules. But is the Sun at the center of the galaxy? No. Its distance from the galactic center is about 8,000 parsec, or, if you prefer, 26,000 light years. Our star takes around 250 million years to go along its orbit around the galactic center. This means that since its formation, it only made around 25 orbits around the center of our Milky Way, traveling at 215 kilometers per second. And it is good that the Sun is not in the center of the galaxy, because in it there is a supermassive black hole, Sagittarius A, a monster with a mass equal to about 4.3 million times the solar mass and an immense gravitational field, such that even light is not able to whisk. And what about the Milky Way? Is it at the center of the universe? Even in this case, the answer is negative. The Milky Way belongs to the local group of galaxies, with a dimension of 10 million light-years, or 3.1 mpc, megaparsec. We remember that 1 mpc is equal to 1 million pc, and that 1 pc equals 326 light-years. The local group includes more than 70 galaxies, most of them of small size. The center of mass of the local group is between the Milky Way and the Andromeda Galaxy M31. And the local group, together with the Eridanus cluster, Fornax cluster, and Virgo cluster of galaxies, belong to the local supercluster, with a diameter of around 110 million light-years. It is thought that our universe contains around 200 billion galaxies, everyone with 200 billion stars. Do you imagine that, with satellites, space probes, and telescopes, we have explored so far only a very little percentage of the universe? In conclusion, our Earth is not at the center of the galaxy, neither of the universe, but only a small planet around a small star which orbits in a peripheral zone of a spiral galaxy, similar to many others. Citing Carl Sagan, is only a mote of dust suspended in a sunbeam. We'll see you in the next episode of The Martian Caveman, where we'll try to uncover the mysteries of our universe. Stay tuned.